adiabatic operation, and basically these are those operations in which no exchange of heat takes place, and we have studied about the essential conditions in the previous video. Now we will know about what is the equation for adiabatic operation and what is the relation between pressure and temperature and volume and temperature for adiabatic operation. Now the equation, gas equation for adiabatic operation will be PV raised to power gamma is equal to constant. Now what is gamma here? Gamma is the specific heat of a gas. We represent gamma is equal to specific heat, which is represented by C at constant pressure, to the specific heat at constant volume. Okay, now we can write this equation as, for the two different states, P1 V1 to power gamma is equal to P2 V2 to power gamma. Now since PV is equal to RT, which is the perfect gas equation, so for finding out the relation between volume and temperature, we will eliminate P. So here, from here we can write P is equal to RT by V. Putting this value in this expression, we will be having, in this expression, the first one, we will be having RT divided by V into V to power gamma is equal to constant. Or we can write this is T V to power gamma. This 1 is taken upside, which will become minus 1. So this will be gamma minus 1, which is equal to constant by R, which is again a constant. So T V to power gamma minus 1 is equal to constant. This is the relation between temperature and volume. Similarly, to find out the relation between pressure and volume, we will eliminate the volume from this equation. So in that case, we will be having V is equal to RT by P. So putting this value in first equation, we will be having P, this is R, T raised to upon P raised to power gamma is equal to constant. So we'll write here P, this is 1 minus gamma T to power gamma, which is equal to constant, taking by R, which is again constant. So this is the relation between the pressure and temperature for the adiabatic processes. Now if we talk about the curves, adiabatic curves will be exactly like that for the isothermal curve, which will be like this curve, because in this case also, when we decrease the pressure, the volume will increase, and again if we increase the pressure, volume will decrease, depending upon the process is compression or the expansion.